Hello students, this is our second video of trigonometric inverse function. I think you have seen first video of inverse trigonometric function. In that video we studied about inverse trigonometric functions. In this video we will study about properties of inverse trigonometric functions. Then in this first property is sine inverse 1 upon x equal cosec inverse x if x greater than equal 0 or x less than equal minus 1. Second one, cos inverse 1 upon x equal sec inverse x and x greater than equal 1 or x less than equal minus 1. And third part is tan inverse 1 upon x equals to cot inverse x greater than 0. In this property we will discuss only one part, that is first part. Similar second and third you can do. So first part is sine inverse 1 upon x. Let sine inverse 1 upon x equal y. Then 1 upon x equal sine y. Therefore x equal 1 upon sine y, or 1 upon sine y means cosec y. Therefore y equal cosec inverse x. Y means sine inverse 1 upon x. So sine inverse 1 upon x equal cosec inverse x. Similarly, you can prove tan inverse x 1 upon x equal cot inverse x and cos inverse 1 upon x equal sec inverse x. Next, second property. Second property is sine inverse minus x equals to minus sine inverse x. X belongs to minus 1 to 1. Second part, tan inverse minus x equals to minus tan inverse x if x belongs to R. And third part, cosec inverse minus x equals to minus cosec inverse x for our modulus x greater than equal 1. In this property, we will also prove a single part, first part, and similarly you can prove second or third part. In first part, let sine inverse minus x equal y, then minus x equal sine y, then x equal minus sine y. And since we know that minus sine theta is sine minus theta, therefore transfer sign, that is sine inverse x equal minus y, then y equal minus sine inverse x. But y is sine inverse minus x, therefore sine inverse minus x equal minus sine inverse x, and x belongs to minus 1 to 1. X belongs to minus 1 to 1, which is domain of sine inverse, So similarly you can prove second or third part also. Yes, next third property. Third property also similar to second property. Cos inverse minus x equal pi minus cos inverse x for x belongs to minus 1 to 1. Cot inverse minus x equal pi minus cot inverse x for x belongs to R. And third part is sec inverse minus x equals to pi minus sec inverse x. In this also we prove first part only. First part, let cos inverse minus x equal y, then minus x equal cos y, x equal minus cos y. And since we know that minus cos theta is in second quadrant means pi minus theta, that is pi minus y. Minus cos y equal cos pi minus y, then cos inverse x equal pi minus y, then y equal pi minus cos inverse x, and y is cos inverse minus x. Therefore cos inverse minus x equal pi minus cos inverse x, where x belongs to minus 1 to 1, which is domain of a cos inverse. So similarly we can prove second or third part, cot inverse and sec inverse. Now fourth property. From 10th class we have seen that sin 90 minus theta equal cos theta, cos 90 minus theta equal tan theta, sin theta, tan 90 minus theta equals to cot theta, and cot 90 minus theta equal tan theta, sec 90 minus theta equals to cosec theta, and cosec 90 minus theta equal sec theta. From this we prove these properties, that is sin inverse x plus cos inverse x equal 90, that is pi by 2, tan inverse x plus cot inverse x equal pi by 2, sec inverse x plus cosec inverse x equal pi by 2. So for this also we prove only first part. First part, let sin inverse x equal y. Let sin inverse x equal y. Then x equal sin y. X equal sin y. So for this property we have to convert in cos. Sin y, since we know that sin y is cos 90 minus y. Therefore cos inverse x equal 90 minus y, and y is sin inverse x. Therefore pi by 2 minus sin inverse x. Cos inverse x equal this. Therefore transfer sin inverse x. Then sin inverse x plus cos inverse x equal pi by 2. So this is first part of this property, sin inverse x plus cos inverse x equal pi by 2, where x belongs to minus 1 to 1, which is domain of sin and inverse and cos inverse. Similarly, you can prove second or third part of this property. Yes, fifth property, tan inverse x plus tan inverse y equal tan inverse x plus y upon 1 minus xy. Tan inverse x plus tan inverse y equal tan inverse x plus y upon 1 minus xy, where xy less than 1. And second part is tan inverse x minus tan inverse y equal tan inverse x minus y upon 1 plus xy. In this also we prove only first part. Similarly, you can prove second part. So therefore first part or first or second part, for this we know that tan a plus b identity, tan a plus b, that is tan a plus tan b upon 1 minus tan a tan b. From this identity, since we know that tan a plus b equal tan a plus tan b upon 1 minus tan a tan b. Tan a plus b equal tan a plus tan b upon 1 minus tan a tan b. So since tan a plus tan b, that is x plus y upon 1 minus xy format, therefore let tan a equal x and tan b equals to y. Tan b equals to y. Tan a equals to x, it means a equal tan inverse x, and tan b equal y, that means b equal tan inverse y. So put this value in this identity, tan a plus b. So therefore tan a means tan inverse x plus b means tan inverse y equal tan a plus tan b, that is x plus y upon 1 minus tan a tan b, 1 minus xy. Now transfer this tan, that is inverse of tan. So therefore tan inverse x plus tan inverse y equal, ये tan ट्रांसफर हो जाएगा, that means tan inverse x plus y upon 1 minus xy. This is first part of this identity. So tan inverse x plus tan inverse y equal tan inverse x plus y upon 1 minus xy. So similarly you can prove second part, or for second part we will use identity tan a minus b. Tan a minus b means tan a minus tan b upon 1 plus tan a tan b for second part. Sixth property is 2 tan inverse x equal tan inverse 2x upon 1 plus sin inverse 2x upon 1 plus x square. First part, 2 tan inverse x equal sin inverse 2x upon 1 plus x square. Second part, 2 tan inverse x equal cos inverse 1 minus x square upon 1 plus x square. Third part, 2 tan inverse x equal tan inverse 2x upon 1 minus x square. All three identities which have left side is equal, but right side, in first part sin inverse, second part cos inverse, third part tan inverse. For this identity, these properties, we will use sin 2 theta, cos 2 theta and tan 2 theta identities in form of tan theta. We have read in 11th class sin 2 theta equal 2 tan theta upon 1 plus tan square theta. Similarly, cos 2 theta equal 1 minus tan square theta upon 1 plus tan square theta, and last tan 2 theta equals to 2 tan theta upon 1 minus tan square theta. So these three identities in tan theta form, sin 2 theta, cos 2 theta and tan 2 theta, we will use is in first part sin 2 theta, second part cos 2 theta and third part tan 2 theta. So in first part, in this also we will prove first part, and second and third part you can all prove. First part, 2 tan inverse x equals sin inverse 2x upon 1 plus x square. Since we know that sin 2 theta equal 2 tan theta upon 1 plus tan square theta. In this, if we match 2 tan theta upon 1 plus tan square theta, that is x equal tan theta. So therefore, let x equal tan theta. X equal tan theta means theta equal tan inverse x, and put this value in this identity. So sin 2 theta, theta means tan inverse x. Sin 2 theta, sin 2 theta, theta means tan inverse x equal 2 tan theta. 2 tan theta is x, 2x upon 1 plus tan square theta, that is x square. Now inverse of sin 2 tan inverse x equal sin inverse 2x upon 1 plus x square. So therefore, 2 tan inverse x equals sin inverse 2x upon 1 plus x square, which is our first part. Similarly, you can prove second and third part also. Some another properties are also there. First, sin inverse x plus sin inverse y, or sin inverse x minus sin inverse y. Sin inverse x plus minus sin inverse y, that is sin inverse x under root 1 minus y square plus minus y under root 1 minus x square. Second, cos inverse x plus minus cos inverse y equals to cos inverse xy minus plus root 1 minus x square root 1 minus x y square. And third is 3 tan inverse x equal tan inverse 3x minus x cube upon 1 minus 3x square. In these three identities, how do we prove that? Similarly, we have proved just tan inverse x plus tan inverse y, that is tan a plus b identity यूज करके हमने इसको किया. तो sin inverse x plus sin inverse x को हम कैसे लेट करेंगे, कैसे प्रूव करेंगे? For first part, we know that sin a plus b equal sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. I am proving first part only. Second and third you can prove. Sin a plus b equal sin a cos b plus cos a sin b. Then let sin a equal x and sin b equal y. Therefore, a equal sin inverse x and b equal sin inverse y. B equal sin inverse y. But in this identity, sin a and cos a. So now we prove or we find cos a. That is cos a equal, we know that under root 1 minus sin square a. It means root 1 minus x square. Since sin a is x. Similarly, cos b also find root 1 minus sin square b. 1 minus sin square b means root 1 minus y square. Therefore, put this value in the identity sin a plus b equals sin a cos b plus cos a sin b. So for first part, we will prove sin a plus b, that is sin a means sin inverse x plus b means sin inverse y equal sin a cos b. Sin a is x, cos b is under root 1 minus y square plus cos a is under root 1 minus x square, and sin b is y. Therefore, transfer the sign, then sin inverse x plus sin inverse y equal sin inverse x root 1 minus y square plus y root 1 minus x square. Similarly, in case of minus, this identity will be sin a minus b equals sin a cos b minus cos a sin b. And second part, cos inverse x plus cos inverse y, we will use identity cos a plus b. Cos a plus b means cos a cos b minus sin a sin b. And in third part, tan 3 theta, we will use identity tan 3 theta. So in third part, I will show that. So our third part is 3 tan inverse x equal tan inverse 3x minus x cube upon 1 minus 3x square. Since we know that tan 3 theta equal 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now if we match this identity to this, then 3 tan theta minus tan cube theta upon 1 minus 3 tan squared theta. It means we will let x equal tan theta. So therefore, let x equal tan theta. It means theta equal tan inverse x. Then put this value in this identity. X equal tan theta. Tan 3 theta. Tan 3 theta means tan 3 tan inverse x equal 3 tan theta. 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now inverse of tan, therefore 3 tan inverse x equal tan inverse 3x minus x cube upon 1 minus 3x square. So therefore 3 tan inverse x equal tan inverse 3x minus x cube upon 1 minus 3x square. This is also an identity. Yes, example 3. Example 3. Show that sine inverse 2x root 1 minus x square equal to sine inverse x if x belongs to, x lies between minus 1 by root 2 to plus 1 by root 2. Second part is sine inverse 2x root 1 minus x square equal to cos inverse x, but x belongs to lies between 1 by root 2 to 1. So left sides are equal, but right side in this first part is 2 sin inverse x and second part is 2 cos inverse x, and it depend on values of x. For this we know that sin 2 theta equal 2 sin theta cos theta. 2 sin theta cos theta. For first part, since x is lying between 1 by root 2 to minus 1 by root 2. Therefore, sin x lies between, then sin inverse minus 1 by root 2 is less than sin inverse x is less than equal sin inverse 1 by root 2. Therefore, this is minus 5 by 4 less than equal sin inverse x less than equal 5 by 4. Now multiply by 2. Then minus 5 by 2 less than equal 2 sin inverse x less than equal plus 5 by 2. And this is range of sin inverse. So then when we let this, then if value of x lies between this, therefore let x equal sin theta. Let x equal sin theta or sin inverse x equal sin theta or theta equal sin inverse x. Then let sin theta equal x, therefore theta equal sin inverse x, and cos theta is root 1 minus sin square theta. It means root 1 minus x square. Then put the value of this in this identity. Then sin 2 theta means sin inverse x equal 2 sin theta cos theta. 2 sin theta is x and cos theta is root 1 minus x square. Now transferring this sign or taking both sides sin inverse, then 2 sin inverse x equal sin inverse 2x root 1 minus x square. Therefore, in this first part, we let x equal sin theta or sin inverse x equal theta. In second part, x lies between 1 by root 2 to 1. Therefore, if take cos inverse in whole interval, cos inverse 1 by root 2 is pi by 4 and cos inverse 1 is pi. Then 2, then multiply by 2. Therefore, this belongs to pi by 2 to pi. Therefore, this is second part. You can also prove for taking cos theta equal x. Thank you. In next video we will solve the examples of exercise 2.2 and some questions of exercise 2.2. Thank you.